My name is Danon Lawson. I'm the Stormwater Administrator for the City of Gastonia and also the Regional Stormwater Partnership Chair. We're excited to have you today. And if you are a participant in the Regional Stormwater Partnership, welcome to our members. If you are not, and you would like to consider membership, we'd love to talk to you a little bit about that. Or if you'd also like to be one of our sponsors, we'd love to talk to you about that as well. The partnership does have a variety of really good opportunities to enhance your MS4 program and also provide education and outreach within your community. So today, we're going to we'd love to just kind of show you can see some of our municipalities here. Some might be your neighbors, some maybe some folks that you know. Over this, please take a look at who our partnership memberships are. And for further information, you please just contact Carrie Rayburn at risingsolutionsplc.com, and her email's right there. So today's quick agenda, again, I'm Danon Lawson, Stormwater Administrator for the City of Gastonia. We also have, we'll be talking about using 911 call data that's going to be presented by Jamie Watkins of Lowell. Observed changes in rainfall intensity within Mecklenburg County and the status update on completed and ongoing local, statewide, regional, and national IDF reference studies by Joel Nipper. Flood mitigation program tools and mitigation work by Tim Trautman of Mecklenburg County. Practical and proven methods for keeping storm drains clear by Marissa Houston of Mooresville. And we'll be ending with a Q&A for all speakers, which we encourage you to answer pertinent questions. I'd love to engage with you in that. And then we'll be closing promptly at 12 o'clock to make sure that you're not missing any lunch or anything like that. So, but I want to take just a moment to thank our presenters, Jamie Watkins, who's the Stormwater Administrator for Lowell, Joel Nipper of Charlotte, Tim Trautman of Mecklenburg County, and Marissa Houston of Mooresville. So thank you guys for taking the time out of your day to present with your expertise and perspective. We do appreciate that. Couple of things to discuss. This is an interactive webinar, so there is a chat feature available for comments, which is great. There's also a Q&A feature that we would ask each participant, each person today, if they have a question, please use the Q&A feature and not the chat feature. That way we can take a moment to promptly answer questions, comments, anything like that. I see we have a few chats that are coming in right now, and we welcome all participants here, so we thank you for that. There is about a 10-minute Q&A at the end of the workshop. And also, as a quick reminder, you will also be able to receive PDH credits, which I'll get to right here, and your PDH certificate credits for those who need PDHs. There's a QR code. You'll just utilize that QR code, take the evaluation form, and then your PDH verification certificate will be emailed to you. Today's topic is on flooding, and also I think it's important to note that if you are a floodplain manager, you can also get credits for this through the topics that are covered here. All right, so let's get started. And to begin this, I think we're running right on time, or maybe a little bit behind schedule, but our first speaker is Jamie Watkins. Jamie has several certifications in environmental and conservation education, as well as in EMS search and rescue. So Jamie became the Stormwater Administrator for Lowell in North Carolina in August of 2023, and is excited to use her various certifications and expertise to further the mission of protecting water quality of the South Fork River and the people that it serves. When she's not trying to save the planet or save lives, Jamie enjoys hiking, camping, and kayaking with her husband Josh and their dog Nugget. So thank you, Jamie. Welcome. Look forward to your presentation.
Thank you, Danon. And I'm going to share my screen. All right. So, like you said, my name is Jamie Watkins. I worked for the city of Lowell. I just assumed that role about 8-9 months ago now. So I completed a master's degree at the University of North Carolina at Greensboro just a few weeks ago. And my graduate thesis was on flooding calls and stormwater flooding as it pertains to water rescue in Rowan County. So a little bit of backstory here. In 2017, I got the hot idea that it was going to be the coolest thing ever if I gave up my decade-long career as a massage therapist, went back to school, and did something completely different. I wanted to get into conservation, but I didn't know exactly how. And a colleague of mine advised me to go and get my environmental educator certification through the DEQ. And so part of that, I chose to do a 2-day workshop on wilderness first aid, because I figured if I'm going to take people's kids out into wilderness settings and go, look, children, it's nature, appreciate it, then I should have some really good solid first aid skills just in case something went wrong. And I liked that class so much that I decided, well, I'd really love to be able to teach that. And they said, well, you can, but you have to at least be an EMT and have a few years on the truck. And I said, well, I got a gap semester, sure. So I ended up folding in some EMT certifications in between getting the various degrees I needed to get through my bachelor's. And in 2019, I volunteered with the Rowan County Rescue Squad. And for the last 5.5 years, it has been my distinct privilege to serve that community and protect their health, safety, and lives. The Rowan County Rescue Squad's been around for about, I think we're 75 years old this year. 18 different technical rescue disciplines. We are recognized in North Carolina. We do all of those except for alpine rescue. There's just not a lot of alpine area here in the central Piedmont. Current population is just under 150,000. And we estimate that between 1 and 2 million people pass through there on I-85 every day. So we have the potential to affect the lives of literally millions of people each and every day in emergency management there. So the conversation that started it all, as far as the little brainchild for this exercise that became my graduate thesis, one day in 2020, I was out of town, but when you're on, at least in Rowan, when you're on an agency there, either as a volunteer or paid staff, you get an app on your phone that can page you out to a call. So instead of having to wear one of the old clunky clip-on beepers, you've got an app on your phone and it tells you where you're going, what type of call there is. You can look at the call notes, anything the caller has told the 911 center. And I was out of town, but I mean, we just water rescue, just calls popping off. And the next evening was our board meeting. And so I was talking to our head of emergency services for the whole county. I said, man, I missed all the fun yesterday. And he said, yeah, yesterday we had more water rescue calls just yesterday than we normally would for a whole year. And I was like, that sounds like a research question. So a little bit about flooding. We all know this. Floods are some of the most destructive and frequent causes of disasters worldwide. They were estimated to be 40% of all natural disasters between the year 2000 and 2014. They're just going to get more expensive and costly to deal with, both in monetary cost and the toll it takes on human lives, as climate change and land use patterns continue to change. And between 2005 and 2014, 709 deaths were attributed to flooding in the United States, and 69% of those were due to flash flooding. We also have some challenges with mapping flash flooding in particular, because land use changes play such a big role in that. But there's something called hidden urbanization. So, you know, there's your as-builts where a developer says, okay, here's the footprint of this building and the sidewalk and the driveway. But later on, maybe a homeowner adds a back deck. Maybe they expand that garage. Maybe they add a little she shed in the backyard. That's added impervious surface that's not always formally captured by some of our mapping. And then to boot, when you're dealing with flash flooding, you know, a lot of times that takes place outside of what the FEMA floodway, you know, designated flood zone maps are. One of these studies that I looked at from my literature review found that when they were analyzing 311 non-emergency calls that were related to flooding in Houston during Hurricane Harvey, they found that over half of those calls associated with flooding were associated with locations that were outside of what FEMA had designated as the flood zone. There was a similar study done in Spain in 2021 to 2023. And these two folks, Oliva and Alsina, used the 211, which is the 911 equivalent. In Spain, they call data from there to map flood extent, and they found out that, like, hey, this is a really great way we can kind of fill some holes in our knowledge gaps. The other good thing about, or the other useful thing about user-generated data, so whether it is Twitter posts, 911 calls, you know, citizen science logging information on their phones on an app, while that information is oftentimes hard to verify, we can get details that no other source of information is going to give us. With 911 calls in particular, people on the ground can give the dispatcher, you know, eye-level ground conditions that no other methodology is going to capture. All right, so I wanted to look at, well, first, when Chief Crest said, hey, we had more calls in one day than we normally would for 1 year, I wanted to see if that was true or if that was just, you know, well, it just seemed like a lot. So I started with a public 911's record request. This is information that's available to anybody. You go on the Rowan County website, say, hey, I want these records this year to this year, anything coded as a water rescue call. Well, my initial results only turned up a handful of calls for that whole time. And one in particular was missing, and I knew it was missing because I was on it. I remember distinctly because that was the night that I turned my ankle on the side of the lake while we were looking for somebody who had run a jet ski aground at 11:30 at night. So that kind of thing tends to stick with you. I knew the exact date of that call because I had to write up a report to my chief about why Jamie sprained her ankle on scene. And if that one was missing, then what else was missing? So I sat down with the associate chief of the rescue squad, who is also the chief over all of 911 operations for the county, and explained to him my little conundrum. And so we did something called a wildcard search. So basically that's a keyword search through all the call notes. So not what it's coded as in EMD, the emergency dispatch system, but what, you know, what was said in the call notes. And so that returned almost 1,000 different calls that I had to sift through and look and make sure that it wasn't floodlights or somebody's basement was flooded because of pipe burst. Once I had gleaned all of those, that really filled in the gaps, and I probably got another 120 records out of that search. It more than tripled my total number of records. I then went about geocoding those because a lot of those I only had like a street address, like the 500 block of Main Street. So I could geocode those. And then I used GIS to plot X and Y data. The next thing I did was download NLCD, so the National Land Cover Database. Downloaded some data from them to do my analysis, and then the EPA has something called an EJ screen tool, and we'll talk about that in a minute. So these are all the calls that fit my criteria, which was, it was related to, it was a flood rescue, but it was not out on High Rock Lake. So not recreation related. And so we've got only a smattering of calls for the year 2015 and the year 2017. And then 2018 comes along and says, hey, y'all, watch this. So much more calls in 2018. 2020, though, that was the year where Chief and I had that conversation, and boom, calls through the roof. What I thought was really significant was previously, you know, right, this is all municipal area, but what's going on out here? This is all out in the county. This is all God's country here. Why are we getting so many calls here suddenly? So by the numbers, we had calls per event, you know, December, 7 calls. January and April 2017, so 2017, 4 calls. August of 2018, we had 32 calls for flooding. The August event is the one I believe that Chief and I were talking about, 17 calls for that one. November was a whopper though. November, we had 90 calls, and that was stretched out over 3 days. The most of those were on one day, but we had a couple trickle in a few days after flooding got started. So this is our land cover data. You've got 15 different types of land cover. They are open water, developed open space, developed low intensity, developed medium intensity, developed high intensity, barren land, deciduous forest, evergreen forest, mixed forest, herbaceous, shrub/scrub, hay pasture, cultivated crops, woody wetlands, and then emergent herbaceous wetlands. So I did a little analysis on the county as a whole, and then I did an iterative buffer analysis. So basically, this is showing where, for all my 2018 calls, I plotted all of them and then had ArcGIS throw out a little 1 kilometer buffer around each of those calls, and then use that to extract the land cover data for both the year 2011, because that was the farthest back of calls that I had. So that was what I considered my baseline land cover data. So extract that for for where these calls were in 2011, and then do the same thing the event year of the call. So I want to see, how did the land cover change in these areas from 2011 to 2018 or 2020, whichever set of calls I was studying, and then compare that to the call areas versus the county as a whole. Because I was thinking, like, there's got to be some sort of change here. There's got to be something different between those two areas. And so what I found was, at the 1 kilometer to 1.5 kilometer buffer size, if you get into 2 and 2.5 kilometers, you lose, you're starting to look more like the county as a whole. There's not as pronounced a difference. So this is just looking at the changes. And a lot of these changes are really minute when you look at just individual ones until you get to the medium and high intensity development. But what I was expecting, so this is our 2018 1.5 kilometer buffers. So we lost 0.15% of the developed open space that was present in 2011 was no longer there. We gained a little bit in low intensity development. Medium intensity development, we gained 8.72% over what was there in 2011, but for the county, it was higher. It was 13.33. And I thought that was interesting, because I was, in my head, I figured that would be flip-flopped. I figured it would be the buffer area would have larger gains. And the same thing with 2020. We had some significant gains in medium and high intensity development, but the county as a whole versus those buffer areas had more pronounced increase in that. So then this is just the conditions on the ground in the year events. So this is where maybe a little bit of some previous lit review kind of comes into play. So when I added all of these highlighted things up, I just broke it down basically into these four I'm going to consider impervious surface. Everything else I'm going to consider, permeable surface. Because one of the articles I've reviewed for my literature review had found that when you pass the 20 to 25% threshold of impervious surface in a given area, that's when you pass the threshold from minor stream alterations to major stream alterations. So that's kind of the tipping point between you're going to have a few problems to a whole lot of problems potentially. So this is just the composition versus the county changes. Again, the county had more changes, a higher amount of impervious surface gains than the buffer areas. But when you look at the composition on the event years, you've got 29, almost 30% of your call area for the 2018 calls and 25% of your 2020 calls. So that kind of tracks with that previous study that I mentioned. All right, so this is the EJ screen tool. So one of the things that one of my professors wanted me to consider was, the idea of environmental injustice, because a lot of times, lower income housing, people of color, people with disabilities, people over the age of 64, et cetera, tend to live in areas that are impacted by one or more environmental justice issues, in our case, flooding. And so I did an analysis of how many of those calls total took place in an area that was considered EJ, one of the EJ screen things. I had picked people of color, low income, and over age 64 as the three I was going to look at. So we had, at least a quarter of all calls were in a low income area. Almost the same for senior citizens, people of color, 17, maybe, that's where, let me back up. So I didn't do a good job of explaining this. So this is the, I don't know if you can see this, but this is the percentile range. So like when things are in bright red to dark red here, that's where it really exceeds the national average of concentrations of those particular populations. So we had 19% of all of our calls had qualified for at least 2 indicators, and then we had 5 calls where it was all 3. So you had the trifecta there. All right, so what I want to do with this information going forward is, in the fire industry, we have done a fantastic job of reducing deaths in structure fires by advocating for better standards to building codes, residential sprinklers, requirements for for commercial buildings to have sprinklers, smoke detectors and carbon monoxide detectors in every home. And I would like to extend that out to things like turn around, don't drown. We found that close to 30%, I think, of all the deaths associated with Hurricane Florence in 2018 were because people drowned in their vehicles. And I know from the call notes that several of the instances of water rescues that I had in my study were because somebody drove around a barricade. Oftentimes you'll put a barricade in place and then leave it there because you've got to go put a barricade up somewhere else. The floodwaters push it a little bit wobbly jawed, and then somebody takes that as an invitation to circumnavigate it. So the thing that I'm looking to do with this data going forward, I'm going to update it with more recent call data. I'm going to do some reverse engineering. So I want to look at those impervious surface areas as they are most recently, and then kind of backwards engineer, okay, what were they in 2011? You know, how much of that was once evergreen forest, mixed forest, shrub, scrub, etc., to try to parse out how much lost evapotranspiration plays into this as well. But ultimately, I hope to kind of put this together into some sort of tool that we can use in both floodplain management, urban planning, and also emergency services for pre-planning, and kind of be able to better forecast events like this so that we can design our training exercises and our response vehicle staging locations and our equipment and personnel budgets to adequately meet the needs of a growing population. And that is my contact information. I have a little, I'm going to throw a link into the chat. It is a survey that I'm going to incorporate into that updated study. Because the next thing I want to do with this research is get it published in a peer-reviewed scientific journal. So part of that updating that info is gathering it's 3 or 4 questions I came up with regarding your experience with using, citizen science generated data in your mapping and studying of flood. So if you guys don't mind taking that survey sometime, either today or later on, I would greatly appreciate it.
Thank you so much, Jamie, for that presentation. I would like all of our audience to know we have a very diverse panel of presenters today, and I think that was a great introduction to the diversity, but the understanding that flooding does impact all of us in some facet or another. Great presentation. Our next presenter is Joel Nipper. Joel is the water quality modeler for the City of Charlotte's Stormwater Quality and Environmental Permitting Program with the Stormwater Service Division. Now, in his role, he develops watershed models to support, in the support of project prioritization and monitoring study feasibility and analysis, and analyzes hydrologic, geospatial, and water quality data to aid in various program requirements and related priorities. Now, prior to joining the city, he began his career as a permit reviewer and site inspector for the state of Vermont's stormwater program, covering post-construction, construction, stormwater, and multi-sector general permitting throughout Addison, Rutland, and Bennington counties. Joel, thank you for presenting. We'd love to see your perspective, and welcome to this presentation.
Okay, thank you, Danon, for the introduction, and Jamie for kicking us off. I'll jump right in. So the overview of what I'm going to cover today, I'm going to start off with some internal rainfall intensity research. Now, some of you may have seen this before. I presented quite a bit on this project 4 or 5 years back. So it'll have a bit of a review and then a bit of an update in terms of what we're seeing in the rainfall network within Charlotte. And then moving on from there, I'll cover a completed study that we contracted a couple years back using, and I'll explain a bit more about this when we get to it, stochastic storm transposition as a method of developing IDF curves from radar data fairly quickly. And then I'll just give a kind of a high-level overview of 4 studies that are currently underway that we're waiting on results in order to formulate programmatic responses. And Charlotte has no role in funding or getting these studies underway. We're just kind of waiting on the results and paying attention. And then lastly, because the topic today is flooding, if I have an extra minute, I'm going to share something about an upcoming forum on the National Water Model, which is a NOAA project that is flooding related and may be of interest. So I'm going to just reuse 2 or 3 slides here to explain how this project works, and then I'll jump off and show the newer results. So this is from the WRI conference, 5 years back now. And it's about rainfall intensity using the 72 rain gauge network we have in Charlotte and some of the NOAA airport gauges, which have longer term records. So just to explain how this analysis works, this is 60 or 70 years of record at the airport in Charlotte. There's a National Weather Service gauge that goes back to the 40s. So that's our long-term data set that we have available. And I've used a storm separation algorithm basically to pick out all of the discrete storms, and they're alternately colored here in red or salmon or blue. So just zooming in here on like a 6-day period, you can see 3 events that are picked up, and then around Saturday there's a couple of bars that are just gray, which don't meet the event threshold, and so they're not counted as storms. And then since this is hourly data, the tallest bar, which is bolded on each of these, is the maximum hourly intensity for that event. And so those are captured again by the bolded bars, and they're in the table. So for event 2, the maximum hourly intensity for that event was about 0.28 inches per hour. Then to proceed with the analysis, I set up a 10-year sliding window. So all the events in this graph here, there's about 4,100 over the 60, 70 years. In this 10-year window, there's 596 storm events, each of which has a maximum hourly intensity that was pulled out. And so then in the graph, the inset graph here, that point is the 90th percentile of those maximum hourly intensities. So in that 10 years, there's about 600 events. 60 of them had a maximum hourly intensity that was greater than 0.62 or whatever that point is. And the other 530 were less than that. So it's the 90th percentile for all the storms in that 10-year window. And then we slide that 10-year window back, doing the same thing along the way, and we start to get a graph of results. So down here in the bottom is the full results for the Charlotte airport. And this I haven't updated because the NOAA gauge records are very laborious to work with. I've updated only the USGS ones we have in the county. But this is going back to the 2018-2019 analysis. This is the full period of record analysis for that per event, maximum hourly intensity binned in a 10-year sliding window analysis. And those first couple of points should look familiar from that last graph. Now, if we start overlaying the USGS gauges, we sort of denote them as the Charlotte Rain Network, CRN. And so there's CRN 1 up to 72. And so CRN 1 here, again, doesn't go back in time as far because we just kicked that network up in the early 90s. We see this kind of rising trend in rainfall intensity over the period of record. And in this case, there's a solid line there because a linear regression fits those data reasonably well. We move on to CRN2, we see kind of an inverted U shape where intensity looks like it was coming up through the early 2000s and then it's kind of going down. And so there's not a regression that fits that in a strict linear sense. And then CRN64 was the sole gauge where we can actually fit a downward line to the data that were available in 2019. Rather than walking through 72 graphs, I have this summarized in sort of a mapped form. So here's a map of the Mecklenburg County area. All of the dots are rain gauges. Black dots have no trend like CRN2. Red dots have an upward trend, somewhat like CRN1, and then CRN64 dot is shown there in blue with the airport in the purple star. Now for the update, I'm going to jump out of the slides here and go over to kind of an interactive dashboard where I keep some of this a little easier than PowerPoint. So the number of red dots in this map, you'll probably notice, is less. Like it's about 7 compared to 2024 or so. So we've lost some of our strict linear upward trends in rainfall intensity when we start adding in the newer data, but I'll show you what that looks like. So starting with CRN1, which was the first overlay graph, before we had this upward trend through about here, assuming you can see my mouse cursor. And so the new data, we have this bit of a downturn. And so that breaks the linear regression at the various statistical thresholds I have over here for saying what's significant versus not. But it's not a total loss or it's not a total reversal. I'm gonna walk through a couple here. CRN2 was that kind of inverted U, and so you can see that in the initial part of the data, but then in the more recent years, we have some higher values. So that's what happened at CRN2. I'm only going to go as far as 6. Don't worry, we're not doing all these. CRN3, we had upward trajectory on rainfall intensity along with the airport, and then we've kind of plateaued here, similar to what we saw at 1. CRN4, same thing, more or less, strong upward trend, and then a plateauing. CRN5, we seem to have just a consistent upward trend without that downturn / plateau. Same thing at CRN6, more or less. So for a lot of these sites, we've lost the ability to say that a straight line very well fits the trend, but we still have more or less the same issue of increased rainfall intensity that we were looking at before. So moving on to kind of what happens next, I'm going to back up a bit. So our current stormwater design manual numbers in Charlotte, Mecklenburg County are actually still based on the federal reports from the 60s and 70s, TP40 and Hydra 35. So Atlas 14 Volume 2 for kind of the mid-Atlantic area came out around 2000. And my understanding wasn't around, we evaluated at the time, and the numbers really weren't that different. And so it's a lot of trouble to go through and update everything. But given the lack of significant change in most of the IDF numbers, we kind of stuck with what we had. However, the USGS network, as I mentioned, was spun up in the early 90s, and so it wasn't actually used in Atlas 14 Volume 2, as I understand it, because a lot of the gauge records were only 7 or 8 years old, and so it didn't really meet the level of period of record that NOAA would use on that analysis. But we had some big storms in Mecklenburg County in 95 and 97 that kind of weren't factored in. And so given all that, we ended up contracting with Curtis Weaver at USGS in Raleigh to do basically an Atlas 14 type study, but focus just on the Mecklenburg County and surrounding area, and do actually a couple of iterations, like what if you use our data as is, what if you average it, what if you exclude those major storms, and give us kind of a broader array of what the results could look like when you use all of the available data. And Curtis, I think, did a great job on that report. The problem is the gauge network was so young that we had these kind of different scenarios, and so you could use one and get a extreme value, or you could use another and you get the same value, and it wasn't really ready to give a confident direction for revision of numbers. That was 2004, 2005, 2006, somewhere in there. And then we did not a whole lot on this for a while until we started looking at this in 2018, 2019. Following the internal research and some talk about, hey, maybe we should revisit these numbers, we reached out to USGS again and said, hey, you know, the USGS network is now 25 years old. And Curtis agreed that, in fact, he could probably do a higher confident job with the longer records that were now available. So we were talking to them about what that might look like. In short, it would look like a couple of years and maybe a couple $100,000. While we were talking about that, we learned that NOAA Atlas 14 was going to be updated for our region, and that would also take a few years, but it would kind of be a duplication of effort to have USGS do something when we suddenly found out that NOAA was going to redo it. Since that was going to take a long time, we ended up doing this Colorado State study, which I'm going to get to in just a second here. And then we learned about a few other studies shown here, which we'll talk about in turn, and then we'll come back to this chart at the end. So the scale for these studies I thought would just be useful to go through quickly. The SST Colorado State study that we funded was focused just on Mecklenburg County because that's where we're at. NCDOT has funded some researchers at North Carolina State University with a NOAA affiliation as well to do an analysis of the whole state on future precip expectations. So that's statewide. The update on Atlas 14, which will be volume 13 of that, which is underway, is sort of subscriber funded, whatever states sign up that are contiguous. And in this case, it's South Carolina, North Carolina, Virginia, Delaware, Maryland, Pennsylvania, and DC. And then Atlas 15 volumes 1 and 2 are also currently underway, and they're at a national scale. So there's a bit to keep track of. But for the Colorado State Stochastic Storm Transition Study that we funded, I, with permission, borrowed some slides from our researchers. So Dr. Lee, well, let me start with Daniel Wright, is a professor at University of Wisconsin who did a lot to move stochastic storm transposition from kind of theoretical into applied with a Python library that he developed, and he's at University of Wisconsin. Dr. Lee did his postdoc there, and so worked on this for a few years before heading off to Colorado State, where he now is. And so we contracted primarily with Dr. Lee to do a radar-based analysis for our area. So this is very dense and complicated, but I'm going to give you kind of the high-level overview. The key term is space for time. And so for normal IDF analysis, you want a long record. You want, decades, maybe 100 years would be great. If you, in SST, instead of having long-term records, because we don't have high-resolution radar, which this uses from before 2000 or so that's available, you can use a broader area. So if you think that storms occur in the surrounding area that hypothetically could have affected the area of interest, that being Mecklenburg County in this case, you can kind of collect those storms in your space for time substitution. And so the rectangle shape here is kind of the area that was found to be climatologically similar enough to Charlotte that you could kind of scrape storms from there and use them in this analysis. So here's some examples of a tropical storm and a convective storm that can be used in this analysis. And the transposition part of that is you take those storms and you restart them from someplace closer to Mecklenburg County. So even if they didn't originally hit Mecklenburg County, you simulate what would have happened if they went over us. That process is referred to as creating a storm catalog. And so in our case, they actually found 475 storms from 2002 to 2020 that hypothetically could have impacted Charlotte. And in some cases, those get adjusted. There's kind of a lot to it. But then there's simulated years where every year you grab maybe 20 of those and simulate them going over. And from that, you then can develop your synthetic 100 years and your IDF curves based on that. So here's two of the result plots. There's some fairly obvious things here. They're overlaid with the Atlas 14 Volume 2. So that's the existing Atlas 14 for our area in blue. And so at the low end, SST, which the software that uses that, the software that performs that is referred to as rainy day. So they're kind of the same thing in this context. The values were lower and then higher with a crossover point around the 100 years. Return period for 6-hour duration and around 25 to 50 years for the 100-year duration. The interpretation we got from the researchers, both in the report and in their presentations, is that the reason that SST is showing higher values at the infrequent level is due to the storms that we've had since 2002, which weren't captured in Atlas 14. As to why the values might be lower at the more frequent return periods, I don't have enough time to go through it, but they have there's an issue referred to as lower bound bias about how smaller storms are simulated. And so they said they don't have high confidence that Atlas 14 was overestimating these, just that SST has not really captured it correctly. So that's it on SST for now. I have a full report. You could contact me if you'd like more on that. And so I'm going to move into Atlas 14 Volume 13, which is the underway update. And let me just blow this up. So Atlas 14 Volume 2 covered kind of Illinois over to New Jersey down to South Carolina. Volume 13 is only covering this kind of weird green shaded area because those are the states that agreed to pay for it. It will include incremental improvements. The most recent published version is Texas Volume 11 that was completed. And they made a number of technical improvements in the Atlas 14 methodology since Volume 2 that were implemented in the Texas version, which would then be adopted into Volume 13 as well. And I just pulled some schedule information from their website with a draft version for peer review, maybe by the end of this year, and a final web publication of everything, maybe by the end of 2025. And this you're probably familiar with is the standard Atlas 14 website where you can go and put in your site and get your various numbers and stuff. So this will be updated for North Carolina and South Carolina sometime by next year. The next study, which I'm most excited about and have probably the weakest slides for, because I didn't really have any content to throw together, is this NCDOT-funded future precip study. And so got kind of all the important stuff here. The lead investigator is Jared Bowden, who is a research professor position at NC State when this started. He's now the associate director of the state climate office. but still working on mostly all the same stuff. The other investigators are NC State professors, somebody affiliated with NOAA, and someone else from the climate office. And the project is titled Quantifying Future Precip Extremes Within North Carolina for Resilient Design. Now, this is just kind of a generic web graphic that I got to hopefully help explain this. This is future precip only. This is about what to expect in the future with respect to IDF curves, and what they're trying to come up with are adjustment factors, where you would say in 2050, if we emit a certain amount of carbon, what would we expect to happen to our 100-year storm depth? And so this is just kind of a general figure about the global climate models that are used to make the high-level predictions. There's a whole basket of them, and they get on a rolling basis approved or disapproved, so that just the best ones are kind of used going forward. And then from that, they predict at sort of a hundreds of square kilometer level. That output has to then be downscaled, which is another statistical procedure to try to get more local scale information out of it. And then they use that to develop these factors. And so, for example, these representative concentration pathways are kind of the relative amounts of carbon that might be put out, where right now I think RCP 4.5 is considered by a lot of folks to be like most likely what we're doing, whereas 8.5 would be if we do no mitigation and just burn massive amounts of carbon out into 2050 or 2100. So from the results of the NCDOT funded study that we're talking about, you would have something like for 2050, if you assume scenario RCP 4.5, you would get some value X between, say, 0.9 and 1.3 that you could multiply your existing 100-year, 24-hour depth, which might be from Atlas 14 by, to say, well, that's what we would expect it to be under that future scenario with these conditions. And same, you could use the later period or different scenarios. And this would all be then at a resolution the same as Atlas 14 for the state of North Carolina, where you could say, what's my scale factor for whatever given depth, duration, location, scenario, and 2050 or 2100. This should be published. It could be like any day. I would be surprised if we don't see something by the fall. It's rolled back a few times because they continually expanded the scope. It was initially Eastern North Carolina only, and they were going to produce results for county centroids, but now it's statewide, and it's going to be this continuous ISO map. And so my understanding is they're very close. Lastly, Atlas 15 was funded in 2022. And so in the past, I've sort of talked about Atlas 14 is funded by states. So states have to say, hey, we'd like this analysis done, and get together, pool their money, give it to NOAA Hydrometeorological Design Study Center, and they'll do it. But the problem is not all the states want to do it, and they happen on different schedules, and so they're not continuous, and it's just kind of a mess. And so the federal government's finally funding a nationwide sort of more continuous effort to do it all at once, along with two other major improvements. One is to deal with non-stationarity in the IDF curve. And so the traditional thinking with Atlas 14 was that over time we would get more data and our estimates would just get better and better, but that doesn't account for the fact that the climate may be changing and those older data might not be representative of what's going on. And so previously Atlas 14 methodology had really no way to account for that other than more data is better and it's all essentially the same. So NOAA funded some studies. I think the Atlas 15 volume 1 study about non-stationarity went to Penn State. So a research group at Penn State that came up with new methods to do the same analysis but account for stationarity so that if things have intensified, we can have current estimates that capture that and sort of use the older data. Volume 2 is something that, again, this NOAA Atlas 14-15 group has never done before. They're doing essentially what the North Carolina DOT funded study is doing for North Carolina, which is take climate models, downscale them, and try to develop regional adjustment factors for IDF curves. And they also outsourced kind of methods to, I think, University of Wisconsin and University of Illinois to say, what are the best development methods? How do we do this? So this is all underway. now. And here's from the flyer that was hyperlinked on that last slide, kind of their schedule. And so continental US completed sometime in 2026. So again, here's the kind of chart of where we're at time-wise. It's a little bit frustrating that there's these overlapping Atlas 14. The last time they're ever going to do an Atlas 14 type analysis will be for our area at the same time that they're rolling out a different methodology for Atlas 15, and we'll get them both in maybe a 12 or 18-year period. So that's what's happening. Again, I anticipate we'll have that North Carolina State study available much sooner, and looking forward to seeing that. And so in the present, we're waiting. And then the last thing is, since this is flooding related, there's this tool that NOAA's been developing called the National Water Model. So the River Forecasting Center does flood forecasting predictions for large river locations, not that many of them. The National Water Model is trying to do the same thing for literally like everything that's first or second order throughout the US. And I'm not going to go and show you how it works. There's a link here, but we've been evaluating it at city and county stormwater to see if their flood predictions will be useful for our own emergency management purposes, and found that in the form that it was last year, it was still a little bit lacking in terms of the forecast reliability. But there's been some improvements made that are underway. So there's this forum coming up in a month. Myself and James Scanlon at the county will be presenting on our use case at this forum. But more importantly, at the beginning, the NOAA developers will be showing how it works, what improvements have been made, and what you can expect going forward. So it's, again, a free tool that could be used for predictive flooding analysis at the 18-hour futurecast level, and also on the longer term horizons. And I think that's it. Yeah. So I'll stop sharing.
Thank you, Joel, for your perspective. That was great information. I think I speak for everyone when we talk about the complexities of whether it's through design or flood mitigation or the value in just the overall value in our rain studies. Thank you for presenting that. And it's interesting to see how we come to some of the decisions that we have and some of the conclusions. I appreciate that perspective. We do have a few questions for you, Joel, if you look in the Q&A section there. As a reminder, if for those who want to ask questions or see some of the questions that were asked, the Q&A portion is a very valuable tool here on Zoom. Our next presenter is Tim Trautman. Tim is the Engineering and Mitigation Program Manager for Charlotte Mecklenburg Stormwater Services here in North Carolina. He has been actively involved in national flood policy issues with the Association of State Floodplain Managers, ASFPM, for the last 15 years. Mr. Trautman oversees a $15 million annual program that includes water quality and flood mitigation, capital improvement projects, local mitigation planning, real-time flood notification, and floodplain map maintenance. So he holds a BS and ME degree in civil engineering from the State University of New York at Buffalo, aka SUNY Buffalo. Thank you, Tim, for your perspective and for joining us today. Certainly look forward to this talk.
Great, thank you very much. Wow, what a great spectrum of presentations today so far. I'm changing gears a little bit and going to talk more programmatic and really try to provide a very probably a fire hose type version of how we manage flood risk and the different programs and policies and technologies that we have in Mecklenburg County related to that. So I'll give a brief overview and history because it's helpful to always have some context of what we've done in the past and what type of issues we have dealt with in the past. Talk just a little bit about how we handle floodplain mapping, talk about mitigation of flood losses, how we reduce risk essentially, and then decision-making tools and different technology that we use to track our success or lack of success. So y'all are very familiar with North Carolina here and Mecklenburg. We have a stormwater utility that we operate under, which I think, probably a dozen or so, maybe more than that, stormwater utilities that I'm aware of in North Carolina. And really our mission related to this part of the stormwater utility is to protect life and property and restore the natural floodplain functions. And everything I'm going to talk about is a program that is working in the mapped floodplain. These aren't stormwater infrastructure projects, pipe type projects. The city of Charlotte handles all of that infrastructure. We deal with these open creek systems, 1 square mile or greater, and try to manage them comprehensively throughout the county. So our history, probably like many of yours, on and off, history of agriculture, of malaria control. So there was a lot of dredging and straightening of stream channels that had a lot of short-term benefits, in the 20s and 30s, but a lot of long-term negative impacts to not only water quality, but also flooding. For many, many years, we did a practice of clear cutting creek banks and have since kind of changed our ways to control flooding. And like many of you, we deal with a lot of flash flooding, urban flash flooding. There's definitely some large river systems in North Carolina, obviously, but most of the things that we deal with, there's very little lead time, and the flooding can start raining in a couple hours later. Anywhere from 1 hour to 6, 7, 8 hours is our lag time typically in a lot of our major streams. So we have to have real-time information and emergency management. So what I usually like to start with is how important it is to have a vision for your floodplain, because everything that you do and the way you manage stormwater should generally revolve around that vision. And ideally, the vision is something that is adopted by your elected officials or supported by your city or county manager in a plan somewhere so that it doesn't ebb and flow. But it really helps the framework of which tools are in your toolbox for your specific community. And in Mecklenburg County, for the last 25 years, generally, this has been the vision of how we want our floodplains to look like in Mecklenburg County. In reality, they're not all going to look like this because we have some housing stock and development in these areas that is there to stay to a large extent. But as you'll see throughout the presentation, we're actively working through both the regulatory side of things with what we're building, as well as undoing development that's occurred so that we can basically let our floodplains flood and use them for other purposes during dry times, like recreation and trees and open space and things like that. But that's the vision for our floodplains that a lot of this is predicated based upon. And your community's vision may be different than this. So real quick, floodplain management summary. These are only a couple of things that I'm going to be really focusing on today. Two main components are, like I mentioned, the mapping and regulations part. So that is, how do we prevent things that are happening today from continuing to increase flood risk 20, 30, 40, 50, 100 years from now? How do we minimize that? And our concept that we've been using now for a while is creating these future conditions floodplains. So trying to look ahead at development, at how watersheds are eventually going to develop, as well as ideally some of the things that Joel talked about related to changes in rainfall patterns, and try to make sure that things that get built today are built to those higher standards, those higher levels. So we're not kind of chasing our tail as things change. So that's one of the core things. And then two, we obviously have existing problems, and how do we kind of stop the bleeding? Kind of repair what's already bleeding is what I should say. And we do that predominantly through floodplain buyouts and through incentivizing people to make retrofits to their homes in the floodplain and buildings so that they can sustain flood damage. The waters come and go, and it's not devastating. So I'll talk about briefly some of these tools as we go along. So why future flood hazard mapping? I think it's become more and more obvious the last 20, 30 years that our hazards are not stationary. And the unfortunate part was as good as the NFIP has been overall when it was created in the 70s, and these flood maps were created because there was nothing before. They created a boundary, as we all know. You're either in or you're out of a floodplain, and that's the public perception. That's the message that has been communicated for over 50 years through the flood maps, and people want to be out of the floodplain and not have to buy flood insurance, and they think their flood risk is zero and that it won't change over time. And unfortunately, that's not the case, as we all know. Watersheds change, technologies get better with mapping. There's erosion areas, sediment shifts, streams around, all sorts of things change and can happen. And so the idea again behind future flood maps, or kind of factors of safety on top of things, is to get ahead of that. So we're not just regulating to what has happened today, which in reality is what has happened in the past, because that's, as Joel pointed out, that is what the basis for a lot of the data is looking backwards at trends. But we also take a lot of pride in how we communicate this information to our citizens, to developers, to folks that need the information. We really have been online, digital, for probably 15 plus years now, even 20 years overall. People don't come and get paper maps from us any longer. They go search addresses and zoom in and point and click and all sorts of things like that. And the state of North Carolina has an awesome flood mapping program and awesome tools for communities that don't have their own systems. And I certainly would encourage everyone to work with them on map updates, so you can really leverage data that they create and maintain through the state of North Carolina. So on our mitigation program, how we reduce risk, there's really kind of 4 main prongs to it. And they also follow an evolution. When we started to do business differently in the late 90s, these are the legs that we stood up over time. We started by chasing after FEMA grants, which I'd imagine most of you who have done mitigation would rely heavily on. And that's all that we did were FEMA related grants where we could get money. We would pay the match with our local stormwater dollars. And we began doing that in 1999 with huge success. Then we stood up a quick buy program, which isn't an ongoing program, but it's basically a reaction to floods. We have a rainy day fund where we kind of sock away unspent operating money, and we each fiscal year, and we kind of build up a reserve so that when there is a flood, we have a reserve fund to go in and offer basically flood buyouts or house retrofits for some of the most severely damaged homes immediately after a flood. Like within weeks, we're talking to people, and typically within a month to 4 or 5 months, depending on how quickly the owners want to move, we are buying these flood damaged properties out in a damaged condition. And it's a really, really good tool that we've had in our toolbox. The third piece, we started just funding local buyouts with our stormwater funding. We realized the FEMA grants added a lot of gray hairs to my head and many of my staff had over the years. And in addition, we were finding that their benefit cost numbers weren't aligning with where we needed to be. And so a lot of our properties weren't qualifying for FEMA grants. So we started doing some of our own local mitigation. And lastly, we created a retrofit program where we use stormwater money and we offer property owners grants that they can apply for to retrofit their homes, put in flood vents, to raise their mechanical equipment out of the floodplain. Extreme cases we help them actually lift their house and build it at a higher elevation. So those are the main tools that we use. In order to have all those tools at our disposal and figure out how to manage the risk and drive our risk, drive things so we become a safer community, we developed a risk assessment risk reduction tool. So that's what you'll hear this term RARR. It's a flood risk assessment risk reduction tool. And basically it takes and it scores the risk based upon data of every property in our community that touches the mapped floodplain. It kind of gives it a numeric score, and it factors in a variety of factors. It's not just how high your finished floor is, but it's also whether you have sheds and fences that could be damaged, or vehicles that could get flooded, or whether your home is actually surrounded by water. Therefore, it's at higher risk because we have to send emergency responders and boats to pull you out during a flood, versus someone whose home maybe is on a walkout basement and they can still have dry access to get off the property. That's a lower risk property. And so the concept is scoring all of these for both mitigation planning and implementation tracking. The general concept here, it's a fairly complicated thing. We have documents that kind of go over our scoring methodology and the different data sets that we use. But we assess the individual flood risk. Then we run it through about 19 different risk reduction actions, from, again, buyouts to house elevations, to relocating houses, to putting in flood vents, to moving mechanical equipment, a whole suite of different things. And we come up with routines to say, based upon our community vision, which of these techniques would we recommend, not recommend, or both would work, multiple would work. So we have an idea of what the best action items are. Then we use the tool to kind of prioritize things. So we're driving risk down, spending money wisely, and that's how we implement a balanced program. This goes into just a little bit more detail with those elements, how we assess that risk in step one. We use 13 different criteria, several of which I just mentioned, and we evaluate 19 risk reduction techniques and kind of assess their general effectiveness. So once we have this data, you can actually do some really powerful things that communicate messages to elected officials, to other leaders, and say, where's our flood risk in our community? Where are we going to need to invest more money or less money over time? And so this is a map of just one example. It's kind of a heat map of sub-watersheds. The city of Charlotte is right in the middle of Mecklenburg County, the uptown Charlotte. And you can kind of see the donut area generally around uptown, which, not surprisingly, was really developed between the 40s and the 70s for the most part, before floodplain maps existed. They still have the highest flood risk, which is the red scores. And the lighter colors are lower risk by watershed. So there's a lot of things that you can do from a planning standpoint and communication standpoint with this kind of information. Finally, another powerful thing that you can do when you have a tool like this is to kind of paint the picture of where we are as a community. And so we've taken all these individual risk scores and we put them in one big bucket and we add them all up, and we can communicate to people, this is the level of our current flood risk. And the points don't mean anything. It's what, 567,000 risk points when you add up the few thousand properties that are in and around the floodplain in Mecklenburg County. And we can set goals. We can set funding allocations and strategies to try to drive that risk down to a certain level by a certain time, and put costs associated with it, and anyway, gain support for kind of a strategic plan for spending money. And one of the more important things about this slide and the next slide that we like to communicate is the risk will never be zero. The flood risk will never be zero. That's not something where we can fix all the flooding problems and it goes away. We're just making it to where, as we have floods and we have bigger floods, there's less risk. And so at the end of the day, if we were to ideally mitigate everything that exists, there still will be flood impacts that we can live with as a community in the future. And that's what's called residual risk. That's also communicated in this kind of timeline graphic. We've got total risk points on the y-axis, and the x-axis is a timeline. The orange box at the bottom is the residual risk, showing that as we go over time and we reduce these risk points in our community, it's not going to get to zero again. but we can set goals and we can track trends over time as we work on and invest in the community. One thing we've done in the last 2 years is we built a very cool risk reduction dashboard. We've had a lot of great data that we've been building the past 20 years. And before we built this dashboard, it was kind of all over the place. And our GIS folks would kind of pull together specialty reports, which they still do. But in this case, we have some predetermined metrics that we now have in a dashboard where we can look at our investments and different risk scores, and we can zoom in on parcels, and we can track things over time in a really comprehensive way. One of the components of that dashboard, and this is just a screenshot of the concept, I don't have a screenshot of the actual dashboard, but this is embedded in it, is we also track our losses avoided. So every time that we have a rain event and a flood event, we figure out what kind of damages were done. And a lot of times it's not the whole county, it's certain neighborhoods along certain creeks that maybe got 4 inches of rain and somewhere else got 1 inch of rain. And so we look at what flooded, and because we've done mitigation of 500 properties or so, typically in a lot of these areas we have losses avoided. We have damage that would have happened that didn't, and so we track that number, and our leaders are very interested in knowing this over time, so they can point to it and say, look what stormwater is doing. You know, yeah, this flood caused damage, but it would have cost even more. So you can see we've this number is actually a little old. We're closer to 40 million. We had an event in January 9th this year that we had some losses avoided and some damage. So I think we're closer to 40 million now and actual losses avoided. Another aspect of our program is we have a really great partnership with the Charlotte Fire Department and Emergency Management. They're a key partner, obviously, in the response. They love all the data and the data sets where we can provide them with knowledge and information so that they can make informed decisions related to staging material, staging equipment, and preparing for flood events. And we do this through an incredible network of both USGS gauges, US Geological Survey gauges, the partnership with them, as well as we've invested in our own kind of lower cost gauge network, where we have gauges that cost maybe a few $1,000s a gauge that are supplementing these other gauges, and they really paint a picture of flood conditions in Mecklenburg County. We have an application called the Flood Information Notification System, FINS for short, and this is where all that rainfall and stage information comes in, and it's shown on maps, and we can see hydrographs and peaks and all sorts of things, and now we actually show inundation maps as well. We have a routine that can map the inundation boundaries that are occurring, and we're working on a predictive piece that can look out, you know, say 6 hours, and show, hey, if this rain comes through, this could be the inundation boundary 6 hours from now. So getting back to our mitigation program, we really started hot and heavy in 1999 on this. We haven't had any federally declared disasters in Mecklenburg County. So we have not had the big event where the states come to us and said, hey, you know, we have $50 million or $20 million because you're a declared county. Let's do mitigation. We've tapped it, obviously. We have not had any disaster declarations. We just haven't had the volume in Charlotte the way our watersheds are. And there you can see some statistics to date. So I'm going to close with a few pictures and examples of where we've done some really comprehensive, cool buyouts and stormwater projects that have taken quite a bit of time and quite a bit of money over the years, but have had tremendous transformational success. Here you can see a neighborhood off of Little Sugar Creek with a big parking lot on the left and all residential in the floodplain on the right. Uptown Charlotte in the background. This was one of our first buyout areas. There you can see we purchased about 80 houses, restored the stream, built a nice greenway. This is part of the Cross Charlotte Trail connection that goes from north of Uptown all the way into South Carolina now. So if you want to do something and take a nice long bike ride or walk, I think it's something like 12 miles. You can go from downtown Charlotte all the way into South Carolina as of about 6 months ago. And that wouldn't happen without some buyouts along the way. Here's an example of commercial redevelopment, a capped creek from the 50s and 60s. The creek was covered, an old shopping mall. And we really leveraged a redevelopment initiative where we partnered with a developer who was already redeveloping the site to uncap the stream, make it healthier, reduce flood losses. They built new development right outside uptown. And now we have an open creek system. We also don't shy away from apartments because there's a significant number of residents that live in flood-prone areas, and the density is obviously more intense. And this was one of our bigger successes. I think between the two apartments on both sides of the creek that run down the middle, there were 420 units that we bought out and cleared from the floodplain. And you can just imagine the emergency response efforts that it takes in the middle of the night to evacuate 450 residents in 15, 20 minutes and all of their vehicles in a safe manner when this floods. And so, not only is there the losses avoided and the damage, but this is an example of significant emergency response logistical savings that really could save lives in the future. And there you can see some of our restoration work that's probably 4 or 5 years old now, these pictures. And last but not least, here's another residential neighborhood with maybe 15 homes along a formerly dredged and straightened and rip-wrapped section of creek that I'm sure was probably ag at some point. And you can see we did a buyout and did some stream restoration and built a big pond. This is 20 years old now, this project. The photos are not, don't have updated aerial photographs, but a really successful project there. So with that, I'll just close and say thank you. Look forward to your questions in a little while, and close again with the slide that I think is the most important, and it's setting your vision for how you would manage and use your floodplains in the future. Thanks.
Thank you so much, Tim, for your perspective. I think it's interesting as we move through each one of these subjects, the subject matter and experts that are behind this. I think it's easy to see that everybody is invested at some level of flood mitigation, stormwater, and that's really the advantage of having this partnership that we have, is the opportunity to idea share and really work together and coming to some maybe some things that we can bring to the table, whether you're in the design field or in the local government. So very exciting stuff that we have here. Our final presenter today is Marissa Houston. Marissa's also on the Regional Stormwater Partnership as our treasurer. I didn't give a shout out to Jamie in the beginning. She's also on there. So we have a few people who are on the board here, but Marissa is the Stormwater Program Manager for the town of Mooresville. She's been with Mooresville for 4 years. In her role, she oversees the development, implementation, and tracking of the town's Phase 2 NPDES permit. And before getting into local government, she worked with the USDA and NRCS, assisting in watershed rehabilitation planning and various conservation programs. She is a graduate of West Virginia University with a BS and MS in natural resource economics. And just a big shout out to you, Marissa. You do great work, and interested to hear what you have to say today. So thank you for presenting.
Thanks, Danon. And also shout out to the NRCS. Danon's also a former USDA NRCS employee. So my presentation, I'm kind of bringing it back to basics a little bit here. So keeping storm drains clear, an approach for smaller maintenance programs. For those of you that don't know, the town of Mooresville, our population is over 50,000. Back in the 90s, it was definitely not. It's had some substantial growth within the past couple decades. Jurisdictional area is about 26.5 square miles. And we have a smaller stormwater staff. We are a Phase 2 community. We have 9 full-time employees, 2 administrative staff, including myself. And then on the maintenance side, we have 7 employees, a stormwater maintenance supervisor, and a crew of 5, and 1 full-time street sweeper. So before 2021, we really had a small town approach because at that point we were still considered a small town. It was really a find it and fix it approach. We would kind of just rely on, hey, getting a phone call saying we have a problem over here, going out, fixing it, calling it a day. So now we're kind of transition more to a proactive approach as opposed to a reactive one. Just kind of a summary of what I'm going to be talking about is the keys to keeping storm drains clear, proactive maintenance, citizen engagement, collaborative approaches, and then data analysis for our work order and service requests. So just for starters, a lot of municipalities have different drainage policies. This is just how we deal with things in the town of Mooresville. We do not deal with clogged drains on private property. So shopping centers, backyards or side yards, businesses, manufacturing buildings, private parking lots, and driveway culverts. As with most policies, there's always exceptions to these guidelines. We'll evaluate those on a case-by-case basis. And always public safety is #1 priority. So if it is something that is going to have a negative impact to our conveyance system, or it can be a public health issue, we're definitely going to go in there and do something. I think in some of the, there's some questions in the registration points about maintenance scenarios of where public responsibility and private responsibility lies. This is just an example of how we deal with it in Mooresville. Like I said, we will maintain everything that's within the public right of way. So town maintained roads, we're going to make sure that those drains and those pipe infrastructure is clear, and that it's operating properly. Anything that's private that you see here in these side yards, backyards, if it's only carrying private water or carrying water from a private property, we're typically not going to maintain that. As I said before, there's always exceptions to that when you're talking about public health and safety, but as a good rule of thumb, if it carries our water, we consider it public infrastructure. So how do we identify maintenance issues? 2 ways are citizen requests for service and our proactive inspection program. In a perfect world, we would only hear from our residents when they're calling to tell us that we're doing an excellent job, but unfortunately that is not the case. We've all gotten those phone calls before from an angry resident or business owner saying, hey, I have flooding going on by my property. Hey, there's some type of maintenance needs to be done on the storm drain. Our goal with this proactive approach is to minimize those citizen requests and get to the issue before it actually becomes a service request or a work order. So part of that proactive inspection program is getting out there and breaking up our stormwater maintenance crew. So as I said, we have 5 active crew members. What we'll do is we will actually break those off into 2 miniature groups. So we have 2 or 3 people that are focused on maintenance and repairs, and then 2 or 3 people that are focused on inspections. I know this was another question that had come up in the registrations, was asking about proactive maintenance programs and if municipalities are using CCTV and pipe cameraing systems. That is something that we do in Mooresville. So as long as our workloads allow for it, if we have a long backlog of repairs, let's say we have 5 or 6 sinkholes that we have to deal with, we're not sending a proactive inspection crew out. We're all hands on deck. But if we have the time and we only have some small repairs that need 2 or 3 people, we will send out those 2 staff. They'll be out in the camera trailer and they will be going into different areas of town and doing those proactive inspections. So that entails visual inspections of inlets, manholes, those different types of structures. And then we'll use the EnviroSight rover, that's the CCTV camera, to take lovely pictures like this from all my friends in different municipalities. I'm sure we've all dealt with one company or another boring through our stormwater pipes. So it's always fun to find a picture like that. There. So the program helps us problem. How so all of our staff in the field has either an iPad or they have a computer with a hotspot, and we have our infrastructure mapped here. and they can do the inspection directly on the asset. So we have 3 conditions that they'll go in there. Condition 1 is clogging, depending on what type of asset it is. Cracks in the box, sagging if you have some sag in the ground. And then it comes up with this condition index. So they are out in the field on the iPad and they are submitting these inspections in real time. So that condition assessment that I said, those 3 conditions, depending on the type of asset it is, you'll have a different condition for 1, 2, and 3. And as you'll see, the most important is the ones that are related to clogging. So that is going to immediately bump up your condition index number if you have significant clogging or a blockage at that pipe or inlet. So you'll see how it's calculated down here. It's just kind of a simple condition matrix. We rate things on a scale of 1.25 to 3.75. So if it's a 3.75, we probably need to get in there, do something relatively fast. And that maintenance prioritization. So the structures, like we said, they're allocated to a repair prioritization list based off of different factors. So it's mainly this condition index number, but we also take into account safety concerns. So we can have a asset that's, let's say it's a 1.75. It's really not that bad. It's considered good for all intents and purposes, but it's actually causing a hole at the road. It's some type of health and safety issue. That automatically jumps to the top of our list. So depending on what it is, we will try to get out there as soon as possible, or we decide that it's not something that actually needs to be addressed. I'm sure we've all had a resident call and say, I have an emergency, I have a sinkhole, and it's like a 3x4 inch small hole next to a box. It's really not a problem. So try to let people know that the action items that need to be done, and then always the barriers that we have, depending on the location, weather, accessibility. We may not be able to get out there as fast as we can. So part of the proactive program is this GIS online dashboard. So this is what our maintenance crew uses to do pretty much everything. So they are working off of these 2 boxes on the left side, needs inspected and open work orders. If they have 0 open work orders, that's a good day. That means we haven't had many citizen calls or complaints saying that we have problems. They can go and work off of this repair prioritization list. So you see right now on our structures, we have a 2.83. That's considered something that's not great. We have a crushed pipe. That's something that they would go out there, and if we had the equipment, the time, the weather on our side, we can go in there and do those proactive repairs. You'll see on the bottom left here too, 4,225. That's how many structure inspections that we've had. We have another indicator there for pipe inspections. And then there's other tabs through here too that say contractor repairs, things like that for in progress construction. So we'll also try to do some proactive inspections before developments are turned over to identify any issues that need to be repaired before street turnover to town maintenance. So how we'll enter our work order and service requests is directly through this work order system here. So they will click on that inlet, and we have that little box that opens up, and it will take you right to survey 123, and they can input that work order and it will update onto this little indicator on the left in real time. So I think that's the biggest part about a smaller town, not so small now, maintenance program is being proactive. We can prevent a lot of this heavy flooding, at least on the localized area and block storm drains, by getting out there, addressing these crushed pipes, getting these smaller maintenance items checked off the list before they become bigger ones. The next element of it is citizen engagement. So education outreach is a huge one. Social media and town voice, we try to put out as much information as possible on a routine basis, just about the do's and do nots of stormwater. The Regional Stormwater Partnership has some great resources there for, say, a citizen's guide to stormwater, BMPs for different types of industry. We'll also send out PSAs just to let people know before heavy storm events, saying, hey, you might want to make sure that you're storm draining from your house. Make sure you don't have any yard waste that's blocking it. Don't put your leaves directly on your storm drain, which you would think is a no-brainer, but and then education question come up, and the right that responsibility lie. A lot of people don't realize that they're responsible for the storm drainage that's in their yard. So they will end up having issues where it gets blocked up, and over time, they don't realize they're supposed to be maintaining it, and it ends up being a larger issue down the road. Another one is just volunteer opportunities, storm drain marking, keeping things out of the storm drain that is going to get them stopped up. Like I said, with yard waste and debris, a lot of people don't realize that that is illicit discharges, and that can have a heavy impact to our storm systems. When you get a lot of those leaves in there, it can block it up, and then you're going to have that localized flooding. We got some pictures on the right-hand side here of just a couple of volunteer events we had. One is the storm drain marking, and then during our Creek Week, we do a couple of different events like that and just spread awareness of the do's and do nots. But one I want to highlight here is our Adopt a Drain program. So I know there's a couple of municipalities in the area that have a program like this, but it is a great way to harness your community and actually help you with your job a little bit. So like I said, we have a smaller program. We have an active crew of 5 employees. Well, we also have 75 residents that are helping us to keep an eye on storm drains out in the field. So we launched this program in April of 2022. Pretty much you sign up, you sign a contract, and it's a 1-year commitment to submit monthly monitoring reports. We have individual and group participation, so just individual residents. We actually have some town staff that adopted storm drains in front of one of the buildings. Different committees, our Environmental Protection Committee, and then the Mooresville High School, their environmental group actually adopted some storm drains in front of the school. So we have this just fully functional website, tells you how to register, how to find a drain near you, and how you clear off a storm drain. We're not leaving people out in the trenches and saying, hey, you got to figure out how to unclear this. It's the small side maintenance where you just have a little bit of trash and debris. If they can handle that for us, it saves a lot of back work on our end. But if it comes down to it, where they are out in the field and they say, hey, we've got some serious issues here, it will notify us in real time. So part of that program, you're going to go and submit your monthly monitoring report, or you're right before a rain event. You click this track observations here. So I'll click on my drain here. That's one that was adopted by our Environmental Protection Committee. I'll say track observations. I'll say, yes, our storm drain was blocked. There was leaves and yard waste. And then you can say, hey, was the blockage removed? If you say no, and it'll automatically go back to this slide. It'll automatically put maintenance request, and it will send a notification to our general email box for the Adopt a Drain program. And you can add any pictures and then information on the types of damage. So this is also part of our proactive inspection program. It may not be town staff that's doing it. It's part of our residents. And I found that the people that are involved in this program are very involved in it. They are taking lots of pictures. They are coming up with very fun and creative names for their storm drains. It kind of gives a little bit of ownership, and then it lets them know, hey, we're here. If you see issues, if there's something going on, well, we will be out there. So when those get sent to our system, that's usually high priority. We'll be out there within the next day, usually, to make sure that that's cleared off, especially if we have a heavy rain event coming. So the next part of this is our collaborative approach. So we have a rain event program where if we're expecting heavy rain, the day before and the day of, our stormwater department will be out just running high priority routes. So if you see on the map, there's these blue lines and these red lines. Those are 2 routes that were established for areas that we know are prone to flooding. They're areas that we've had a lot of service requests and work orders for. They have older and undersized drains. And there's areas with heavy tree cover. So if it's the day before, like a major storm, our entire maintenance crew, they'll be out in pairs of usually 2. They'll have their shovel, they'll have their equipment, and if they drive by a storm drain that looks like it's blocked, they'll be clearing that off, submitting observations, and going on to the next one. The staff will also go off route to address citizen service requests and calls from other departments. We work really close with fire department too. They'll call and say, hey, there's some localized flooding here. They'll let us know and we can go out there. So we are very GIS centric for most of our stormwater sub programs. This is another one that we use field maps and survey 123 for. The inspection procedure is if they find a drain in the field that is clogged, they have to submit an observation report for it. And part of that observation report is if you can't clear off the drain just using hand equipment, you would submit a work order. So that older screen that showed kind of our dashboard of all of our stormwater infrastructure of to be inspected, work orders, prioritization, they can go directly from this map to submit a work order if they have to. So you'll see here, this is kind of what it looks like in survey 123, shows the date and time of all of the observations, the maintenance completed, and then the problem resolution. Here's one of the photos that was attached. Clearly they have a subsurface blockage there. And then this is what the form itself looks like. So you put your vehicle number, date and time, the maintenance completed, and then the problem resolution. If it was cleared and it's working okay, that means they were able to do it with the hand equipment, and then obviously VACL dispatched. Sometimes when we have pretty heavy blockage and they can't get on their own, we have 2 VACLs at the town. One is specifically for our stormwater department, and one is for water sewer. They will get one of the VACLs out and they'll be able to clear that out. But it does get put in our system as a work order for analysis, which I will get to a little bit later. And then part of that collaboration is we have help from other departments. The town does, as part of our phase 2 permit, we have training for all town staff so that they understand stormwater pollution prevention and illicit discharges. Our streets department will actually run storm drains along their assigned plowing routes. So you see this map, all the different colored sections are the plowing routes, and they will have pairs or groups of 3 that they will be going out in the field, the same as our stormwater crew, and they're clearing off storm drains. It's the same thing with the sanitation department. They will run their assigned routes for leaf collection. And if they see something that's blocked or if they have a problem, they'll clear it off. Some situations they can actually use the leaf vac to clear off any blockages. But it's the same situation. They will call us and let us know, hey, we can't get this cleared off. We'll dispatch a vac call out, and then our maintenance crew will go off route to be able to address that. So everything gets put into our work order system after. We do get a lot of calls from the police department, fire, our water sewer department. We're really good at having that collaborative approach to make sure that everyone's on the same page, and we're getting those areas addressed before they become bigger flooding issues. So the last piece of that puzzle is the work order and service request data analysis. So as we said with everything before, everything that we do in terms of inspections, proactive maintenance, everything, it is done in GIS. We use it in ArcGIS Online. This is the same for stormwater control measures. We have 28 town maintained SCMs. We will do all of our inspections and maintenance logs for those in GIS, and we can analyze that data, see where we have trends, see where we have issues. So these can be analyzed in Survey 123 directly or in ArcGIS Online Map Viewer. So just these couple snips here. This is problem code. So this was from our work order and service request dashboard from when we submit everything. You'll see that clogged storm drain and pipe. That is our #1 problem code that we get. Almost 15% of all of our work orders and service requests are clogged storm drains and pipes. So even with us having a strong proactive approach, it's still a problem. We do know that we have some older, undersized infrastructure, but we are trying to do our best to mitigate those areas. You'll see down here, we can also do some filtering of our data. Say, I want to know every clogged storm drain pipe that we have within the last 30 days, and you can see the locations of them. And then this one over here, if we want to say, hey, let's see every service request and work order we had down Magnolia within the past year. we're able to filter those things and see some of that information if we want to do future projects. Magnolia we have a town SCN as part of all this to have in GIS, I think is super helpful, just so that you can know what you have and know where your pain points are. Outside of Survey 123, you can do some pretty basic analysis just within ARC Online. I do some as well, just in ARC Pro, using just spatial analysis and using those tools. But a really easy one here is just using classic heat maps. So these are all of our work orders that are on assets. So any type of inlets, manholes, things like that. And you'll see where these are focused. So if you remember the map that showed the 2 priority routes that our stormwater staff runs, this is kind of right in that corridor. So we know we have a high influx of work orders and service requests, and this is actually the older part of town where we know we have that undersized infrastructure and where we have a little bit heavier tree cover. This is a similar one for those rain event inspection program. These are where they're running those routes. Those are the corridors where we know we have a little bit more problems. And then just another type of analysis is knowing how many times these storm drains were cleaned. So I just ran a filter from when we were doing the rain event inspections and said, hey, how many times were these storm drains cleared off within the past X amount of days? And you'll see these darker assets here. They were cleaned over 9 times. So just within, I think I put 90 days for these, but they've been cleared off 9 times in 90 days. So it's good information for us to have. It helps put the numbers to use. We can consider these for capital improvement projects, areas for upgrades and things like that. So just for a wrap up, proactive maintenance is knowing your problem areas and addressing them before they become problems. Anticipate and prevent those citizen complaints. We love hearing from our residents, but hopefully it's only when it's something good that we did. Community engagement, harnessing those volunteer opportunities, using your community as extra eyes. Joint town effort, using collaborative approaches, try to partner with other departments and committees. We do a lot with our environmental protection committee, things like that. And then the data analysis. There's no point having everything in a digitized system if you're not going to put the numbers to use. So I think I put that right at time. And thank you very much.
It's amazing. Thank you, Marissa. That was very informative, and that was a great presentation. The amazing part here is that I think everyone was on time except for me during the introduction, so I was speaking too much. But we have 15 minutes at the end of this, at the end of our, at the end of this tech talk that we have, and we have several questions that have been answered. Actually, for those who want to review the question and answers, there have been a number of questions that have been asked and answered. Now is certainly a good time to, if anyone has further questions to any of our presenters, whether it's Jamie or Joel, Tim, Marissa, or myself, if there's a general question out there that we can answer, certainly be happy to. Again, this is part of our collaborative effort to better our programs. And I think I can certainly speak for everyone when we say we want to be a large part of what it is we do is to help planning for the future, and maybe mitigate some of the mistakes or decisions that were made in the past that don't necessarily fit with present day. So there's a lot of really good information and experts here in each one of these panels to help us kind of get where we need to be. If I guess at this point I could talk to you too, just real quickly. We did have a number of questions that came in at the onset, and some I actually could be turned into future tech talks, so topics. So there are some that we probably won't be able to answer right away, but I'm going to throw a few of them out here. Specifically, here's one that that maybe someone would wish to answer. It was an interesting question, how to deal with railroads and their storm drains when they cause a problem, because you're dealing with maybe a larger entity that has a bigger presence in your community. How do we as stormwater administrators or floodplain managers, how would we deal with that? Is there someone from the panel that would like to answer that one, or anybody have experience with that?
I'll make a quick comment. We have a little bit of experience, especially where they cross the the mapped creeks. And number one, be prepared to have gears built into your schedule for sure. They don't do anything very quickly. So you got to have a long lead time, unless of course it's an emergency. And two, our experience is, you develop kind of a plan of what you would like to do, and then you need to submit it to them, and you pay review fees for their engineers to look at it. I don't remember exactly what those fees are, but most of the railroads have a process in place, and it costs money to have them look at it. And we've had success eventually getting the easements or permissions that we need to do improvements in the right of way, but it just takes a lot of time.
That's a great perspective and great answer. I know that here in the city of Gastonia, we do have contact personnel from the railroads. It's always good to play nice with them, because at the end of the day, we're all trying to resolve an issue. They don't want to be flooded. We don't want the flooding. And if we can work together to make sure that those lines stay open and the lines of communication stay open, that's really kind of a key point too. So excellent perspective, Tim. Thank you for that. Another question that was out on the floor was how do stormwater and floodplain managers make decisions and communicate about flooding? I think that's kind of that's a huge question. How do we communicate with the public about flooding? I know in years past there were firm maps. There are there's more updated maps. I don't know if there's any other advice other than online services and case by case. Any suggestions from anyone on the panel? I may be following this one back to you, Tim. I don't want to volunteer you, but it is kind of in your wheelhouse on some of this. Any counsel on additional resources that are available or how to outreach?
Yeah, I'll let Jamie comment first. Looked like she had an idea, and then I'll chime in.
Go, Jamie.
So one of the things I'm trying to do here in Lowell is to change that conversation about, why am I paying this rainwater tax and what is all this? And, just in general, like explain to people the importance of what we do. And so I'm starting up a citizen science program. And there's going to be two components where one is anybody who wants to participate needs to come and do a training with me so that they know how to use a handful of pieces of equipment we can get relatively inexpensively. And then from there, they'll be able to access a couple of different little, instead of like a little free library, it's a little free science equipment stand. Go do some water quality measurements, put the data onto our team, and it is shared throughout the globe via a program with NASA called the Globe Citizen Science Initiative. And so I'm trying really hard to use any type of public event we have, whether it's the treat walk at Halloween or music in the park, or just, get out there and start with the kids and send stuff home, with them, so that becomes a repeated conversation at the dinner table, hopefully between mom and dad. And there's the hope that eventually that will kind of give them a better framework to make better decisions about, stormwater management issues as they come up. Does that answer that question?
I think that's a great segue into, and it helps people understand the the difference between, and this is something that you said, because we hear this occasionally, rain tax or something like that. When the truth is, it's an impact fee. So the fee that's assessed to each person is based on their impact, their footprint, and what they're contributing to our system. So having that better understanding and how that impacts flooding, because we don't have combined systems here. Again, that's a better understanding of how this is. You're basically paying into a system to make this a better to mitigate floodwaters and things in the future. We have a number of really good questions here that will likely become presentations. I know that there are a few questions here and a few comments on rain gardens and small footprint reduction things. How do we put bioswales or bioretention in our own property? So that very well maybe a discussion that we'll have with the partnership to put that forward in the future. And it's just rest assured there'll be more good things coming. So stay tuned. And I see I'm seeing a number of seeing a number of questions that have been answered. I just ask again, please review the answers and the questions. I could go through each one of these and and read them, but I think they've been answered really well. Again, thank you to our panel for their expertise and willingness to answer some of these questions. As a reminder too, for anyone seeking the PDHs, there are, let's see, I see there's two questions here. Before we get to the PDH thing, there's two questions here. On one was asked, are there any thoughts from any of the speakers on the role of public political support for the measures and programs discussed? Ooh, now we're getting into the politics. Anyone want to delve into those waters?
Yeah, my quick comment is continually show the value that you're bringing. Track it, show it. Put it in information, because the elected boards are going to change it over. So there's lots of new folks that come in, and the more that you're kind of collecting that, pumping that, showing the value of what you're doing to the citizens, the service you're providing, the more sustainable you'll be able to be related to the political changes that could happen.
I'll second what Tim's saying right there too. That's great. That's a great comment. We have a sort of a statement here internally is that any opportunity to get in front of your council or your commission, whoever you're answering to, elected officials, it's any opportunity to promote stormwater. And I think today's topic in the discussion of flooding is a very real subject that everyone is dealing with. No one wants to deal with a disaster, whether it's, as Tim said, evacuating people within a 20-minute time period, cars and everything. That's a very, whether it's or the things that Jamie was talking about with 911, or it could simply be discussing the rainfall data that Joel was talking about and how that's impacting planning for the future. How does, you want a new subdivision here? Well, you're going to have to put in what's a 10-year storm event. Well, let's talk about that. And even the practical side of what Marissa's saying. So I think any of the topics today, if we get in front of those, that's really a great way to any opportunity to talk to elected officials about that, and its relevance in our community, because we are a passive utility, so we're not metered. We're only important when it rains, but when it rains, we're very important. So that's a great question. Thank you. Kristen, for
Reach with Carolina's host elected officials workshop. It's very important as the elected officials rotate with different people to be able to let them understand what you're doing. And
And to that, I'm going to jump off of what Regina said there too. So if anyone is has a local politician's ear or non-local, state, anybody, politician, any politician's ear, we will be having that hosting a we will be hosting the elected officials conference. I think is that those are usually in March. Are they? Is it March or February?
February, March timeframe.
February, March timeframe. We usually try to make it very palatable. We like to do the face-to-face it, but also have sometimes a hybrid to allow people to see this. So if you know of anyone, keep your eye out because it's a great opportunity for all of us kind of working from a watershed standpoint to get together with our elected officials and for 1150. And I think can we round up for those credits, Virginia? You think nobody's going to call us for this last 2 minutes?
Right.
So for those of you who are
have
interested, yeah, there you go. For anyone that's interested in receiving PDH credits, there is the QR code right here. We'd ask that you would fill out a brief survey for your record of attendance, and you will receive your credits on that. And also, I will be using this for my floodplain managers certification. Anybody else, this will count too for 2 hours towards that. So again, for anyone still on here, thank you for participating. I see we still have 142-ish people that are on here. Thank you for participating today. We hope that you found some valuable information on here. They'd like to discuss or bring up the partnership or presenters, we're always welcome for that feedback as well. Thank you again for our presenters. Again, very valuable information. Can't thank you enough for your perspective and for the time that you've taken today to discuss this with us.